Welcome, students. Today I will cover in electrostatics the important topics, important articles, and the concept which are important in the forthcoming examinations, CBSE examinations, other boards also. So since in last years the exams not held as a 3 hours session, it is only for the 2 hours and 35 marks. But present session in present years we will have 3 hours papers and a total of 70 marks. So all topics are will be covered. Almost all topics will be covered because the paper pattern is different, and there are 36 questions. They have also uh, subsections. So almost 60, around 60 and 60 70 questions will be includes if I take all parts as a whole. So all topics are important, but I will cover those are important for our forthcoming examination 2023. So my first topic is electric dipole. We know that an electric dipole, two equal and opposite charges, when two equal and opposite charges placed at some distance, minus q and this is plus q, when two equal and opposite charge placed at some distance at a small distances, so it formed a electric dipoles. We have to find out electric dipole moment of this one. Generally electric dipole moment represented by P, it is charge multiplication distance between the charges. So since I have placed two charges at the place of A and B, the dipole moment will be charge multiplied distance between them. Distance between these two charges, minus q and plus q. So now it becomes dipole moment become q times of, if I place the distance between them is twice a, it will be q times twice a or twice a q. If the distance between them is a, then it will be q times of a. So I have taken twice a. So it is the value of this dipole moment. Now it is a vector quantity. If it is a vector quantity, it has a direction. The direction of this dipole moment is from minus q charge to plus q charge. So dipole moment has the directions. Direction from minus q to plus q. Now the SI unit, charge times meter. Charge measured in coulomb. Charge measured in coulomb and distance measured in coulomb meter. Its unit is coulomb meter. Now next topic we have to find the dipole moment in two positions. Now we are going to start electric field due to a dipole at an axial point. This is our dipole. It made of two charges, minus q and plus q, and this is the axis of this dipole. So we need to find the electric field due to this dipole at a point of P. It's the distance from the center of A, that is O, is R, and we have take distance between A and B. Distance between minus q and plus q is twice A. It is for our convenient. So we need to find electric fields at the point of P, one by one, first plus q then minus q, and the resultant field at P will be the electric field due to this dipole. Now at the point of P, the electric field due to plus Q. The electric field at P due to plus Q is, it is a vector quantity 1 upon 4 pi epsilon naught charge distance between BP. This is BP. Now how to find this one? This is A and this is R, and it will be your R minus A. It will be R minus A. So by the Coulomb's rule, now its direction is away from this positive charge. It means that along BP. So this is the electric field due to this positive charge P, and the usage along BP. Similarly, the electric field due to minus Q at the point of P will be minus Q is, this is also vector, and don't play the negative value of this one. I utilized in the direction. This direction will be towards the negative charges. So electric field due to this will be along this. Now the value becomes, this is the R and this is A. Now the total distance between A and P, R plus A. R plus A whole square. Now it has the direction along PA. Since electric field is a vector quantity, we need to find the resultant of these two at the point of P vectorially. Now in vectorially, net resultant field E is equal due to positive charge plus due to negative charge. Now since angle between them is 180, and magnitude of EQ is greater than magnitude of E minus. So the magnitude will be here greater than magnitude minus smaller than magnitude. I have utilized here the resultant of two vectors A and B. R square is equal to A square plus B square plus twice AB cos theta. Here angle between A and B is 180. So now the formula becomes A square B square plus twice AB, and theta is pi. Now cos pi is equal to minus 1. Cos pi has the value minus 1, so it becomes A square B square. Now this is minus twice AB, cos twice AB only minus twice AB. Now resultant will be this, if A greater than B, and also B minus A whole square if B greater than A. So resultant is just a difference of these two because they are anti-parallel. Now finally put all these values in equation number first. Equation number first becomes net resultant field at the point of P, charge upon R minus A whole square minus 1 upon 4 pi epsilon naught Q upon R plus A whole square. If I take common from here, taken the common outside, 1 upon 4 pi epsilon naught, and the q is also. Now inside of this becomes r minus a whole square minus r plus a whole square. Simply take the LCM. Now it becomes 1 upon 4 pi epsilon naught, and LCM will be r minus whole square and r plus a whole square, and this term goes this side and this term goes this side, and q is outside. Now finally we have r plus a minus r minus a whole square. Square bracket is closed, and we know that using a square b square, r plus a whole square using the formula, and also r minus a whole square. This result becomes, after calculating from the inside, r square plus a square will be cancelled out from minus r square and minus a square, and 2ra and minus 2ra will be added. So 2ra from here and 2ra from here will be 4ra divided by we know that a minus b and a plus b will be a square minus b square, r square minus a square and the whole square. This will be the whole square. So this is our result, and using the dipole moment on simplifications, now we know that here the dipole moment P is equal to charge multiplied distance between minus q and plus q. It is twice a. So we have to replace twice a q with P. Now the electricity at the point of P due to these charges will be 1 upon 4 pi epsilon naught, and here 2 times of twice a q divided by r square minus a square whole power this. Now finally it becomes, if I replace twice a q with P, it becomes 1 upon 4 pi epsilon naught twice P, the dipole moment of this electric dipole, divided by, yes, this is one formula, and it has another form also. If I say that if r greater a, if P point is far from this electric dipole, since we need to place these two charges minus q plus q at short distances, so in that case 1 upon r square minus a square replaced with 1 upon r square. So it has the square, so it becomes 1 upon r raised to the power. Therefore final value we have E is equal to 1 upon 4 pi epsilon naught twice P upon now it becomes a 2pr divided by r raised to the power 4. Now when r is cancelled, now it becomes finally 1 upon 4 pi epsilon naught twice P divided by r cube. Now its directions will be finally along the dipole axis. So the direction is along OP.